So if we just decide to use X and Y and Z, or whatever, they need to represent the question, right? So the question is, what are the three numbers? So each of those variables should represent one of those numbers. Well, what's to separate the numbers apart from each other? How are we going to tell the numbers apart? And they've done a little bit of that for us here, saying that, and it should make sense that if you have three numbers, one of them has to be the smallest, and one of them has to be the largest, and one would have to be in the middle, okay? So you get to decide what letters you put, you get to decide what order you write them in here, but each one of these needs to represent a number, okay? And my general habit is always to look for the first thing they mention, and that's going to be the first thing that I write down. So it says the smaller number first, so that's going to be my first variable is the smaller number. So X is the smaller number. The next thing it says is the larger number. I think it's kind of weird to put the larger number next and then the middle number last. So I'm going to make a decision here, right? I get to decide. So I'm going to decide to put the larger number last, and then the middle number will go in the middle. But nothing's stopping me from switching that all around. Okay? But each one of those has to represent a number. We have to be able to tell the numbers apart. Which one's the smallest, which one's the middle, which one's the largest. So kind of naming them, but each one of them is a number. And now we need to write some equations. So we have three variables, so that means we need three equations. So we need three equations. So what do we got? Okay, where are you getting that from, Claire? X plus Y plus Z equals 108. Right, they add up to 108, right? Taking that sentence and turning it into an equation. All right, one down, two to go. Z divided by 2 equals X. Maddie, where are you getting Z divided by 2 equals X?
It says the smaller number is half of the larger number.
Okay.
I just divided the larger number by 2, but you could also times the smaller number by 2.
Okay, so Maddie's saying the smaller number is half the larger number, so she just took half of the larger number. But you could also multiply the smaller number by 2 if you wanted. That would be the same as some. Okay. You guys agree with that? Z divided by 2 equals X. Okay. All right, 2 down, 1 to go. Not much unhighlighted there, guys. Three-fourths times Z equals Y. So there's certainly nothing wrong with the way you said that, Maddie. I just would point out that it might be a little bit simpler, and same thing, Ray, like a little bit simpler if, as you guys are reading that, like it says the smaller, right? What's the smaller to us? X. What's this word here mean? Equals, so X equals half the larger. Well, what's larger? Z. Okay. And then when you go in to read the next one, The middle number, well, what's the middle number to us, right? Why was it so important that we do this first? Because now that I see middle number, I say, well, that's y. So y equals 3/4 z, right? So when we were talking about this stuff before, we did that coin problem. It's like, there's 8 less quarters than pennies. And we had to sit there and like, which one's the right way? Do I take the 8 from the quarters or do I take the 8 from the pennies? We had to sit there and really like parse that out, make sure it made sense. The way they're wording this, there is only one way to write this. It literally says x is half of z. That's exactly what the equation is. The word is in math is really important. It's really powerful. That's an equal sign. That x is on one side equal sign. The other stuff is on the other side equal sign. That's the only way to write that. The math you said, Maddie, about saying, okay, that's the same as saying 2 times x. Yeah, that's certainly true. But as far as what they're saying here, that's what the equation is. Okay? And so just making that faster, so you're not sitting here like scratching your head for 5 minutes trying to figure out what to do. This word's really important. Okay? Use it. So I'm just going to adjust these a little bit just to get them to look like this. Not really any particular reason, but I just wanted you guys to see something. Okay? So 1/2 times z is the same thing as z divided by 2, and I'm just flipping the other one around for what Rhea said. But okay, so there's our system. So if we want to turn this into a matrix, next, what's wrong with it? We want to rewrite this as a matrix. There's something wrong with it. What do you mean? Where it would just be the constants, you mean? Okay. So we shouldn't have variables over here, right? All the variables should be on the left side. So what should we do then, Ray? Yep. These are perfectly valid equations, but they're not set up for a matrix. Everything needs to be on all the variables need to be on the left side first. So, x minus 1/2 z equals 0. Y minus 3/4 z equals 0. I don't know why I squished those there. And so then we have, x plus y plus z equals 108. You want to go to a matrix that does need to be in standard form, right? So, and I wrote those that way on purpose, right, to highlight that there is no y, to highlight there is no x. Certainly not anything you guys need to do, but just kind of trying to highlight that for you guys. And so now we can turn that into a matrix. Let me group this stuff real quick. One, 108, 1, 0, negative 1/2, 0, and 0, 1, negative 3/4, 0. So there's our matrix. So right now you guys need to make a decision. Like, do you want to deal with the matrix as it is? Or do you want to get rid of the fractions first, deal with that other matrix? Okay, got one vote for get rid of the fractions. 2 votes. What you guys want to do? You got to make a decision. Like, you want to deal with it as is, you want to change it to make it easier. Rid of the fractions. Okay, we all down for that? Okay, no fractions to get rid of. How are we going to get rid of a 1/2? Times by 2. Okay, how are we going to get rid of a 3/4? Times by 4. Okay, so we're going to take row 2 times 2. We're going to take row 3 times 4. We're going to do both those at the same time. Okay? So 2 times row 2 and 4 times row 3. Okay? Just where do you guys? I was able to do this whole problem here. I did write kind of small, but I was able to do the problem here. If you need to flip to one of your blank pages because you're worried about your handwriting size, then do that. But I am going to be able to, if history repeats itself, I should be able to fit it in this space. So. So 108. So 2 times 1, 2 times 0, 2 times negative 1/2, we negative 1. 2 times 0, 4 times 0, 4 times 1, 4 times negative 3/4, so we negative 3, and 4 times 0. So here's our new matrix, right? Our equivalent matrix, just no fractions. Always good to have our key, our map, our goal, right? If we're trying to get into reduced row echelon form, what's that supposed to look like? 1, 1, 1, 0, 0, 0, whatever, 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 whatever. We need that diagonal of 1s. We need that triangle of 0s. And remember, generally the easiest path through this problem is to follow top to left down, across the bottom, and back up. So we should be looking right up there first. It's already a 1, so move on. We come down here and say, hey, that needs to be a 0. So what are all of our options? How do we get that to be a 0? What can we do? Switch rows, okay. So we could switch rows. Oops, just erase a row, that'll help. There, so we can just switch those rows. What else can we do to get that to be a 0? What? Close, row 1 times.
Row 1. Oh,
right. So row 1 times negative 2 plus row 2 would add to be 0. So we can switch rows, or we can multiply this by negative 2 and then add it to that. What do you want to do? Okay. So Matt's saying if we just switch it, it's just kicking the can down the road, and the 2's going to have to get killed anyways, so we'll have to take care of it later, so might as well just take care of it now. So you guys want to do? Just get rid of the 0 anyways, because we're going to have to do it later. All right. So negative 2 times row 1 plus row 2. I'm not going to write the arrow after that just because I'm going to save space. But I'm not changing row 1, so I'm bringing that straight over. Not changing row 3, so I'm bringing that straight over. Multiply by negative 2, negative 2, negative 2, that goes negative 2/16. And I want to add, 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 add. So we get 0, negative 2, negative 3, and negative 2/16. Okay? So we got 0, and kind of got a free 0. So that first column's done. That's nice. And now we have a 4 here. We want that to be what? 1, 3, 0. So what are our choices, right? How do we get zeros? We can flip. There's nothing to flip. We multiply by something, but there's nothing to multiply 4 by to get 0 because we can't multiply by 0. So that leaves us with, well, 1 choice. We don't have many choices, right? We need to add 4 to that, or negative 4. So turn that into a -4 pretty easily. We also turn that into a -4, but if we use this row, it's going to mess up our 0. So we don't want to do that. Which the only thing we can do is multiply this by 2 and add it to that. We have choices, but this is by far the best one, really the only one. So 2 times row 2 plus row 3. We got 0, -4, -6, and -432. I multiply by row 2, or 2 by row 2. We got 0, 0, -9, and then -432. Okay. So we're at 1, 0, 0, 0, 1. Oh, need a 1. How do we get a 1? Yep, divide everything by -9. That's good because those zeros will just stay zeros. So, yep, division right now is a good bet. Hopefully -9 goes into -432. So row 3 divided by -9, or you could do row 3 times -1/9, but 1/9 is not a fraction you're probably too familiar with, so dividing by 9 is probably easier. So 9 goes into 43, 4 times, 7 left over, 72, 8, so 48, is that 48? All right. Yep. All right. So we've 1, 0, 0, 0, 1, so we just need to go back up here and turn this into a 1. That'd be our last step. We go and say, well, how can I get -2 to be 1? Well, I could divide it by -2, just like we did here. If we divide by -2, we are going to end up with a fraction or a decimal here. So the other option would be, there's nothing I can add to it. So the other option would be to, and we've done this, you could kill that 3, turn that into a 0, and then that would free up the 2 to kind of do whatever it wants. So we could just go ahead and deal with the fraction / decimal right now. We just want to be done with it, or we could kill the 0 and then deal with the 2. Kill the 3 and then do the 2. So what do you guys want to do? Want to just go ahead and divide, or do you want to get this to be a 0 then divide? Maddie says be done with it. Okay. And it's not a bad division either because it's divided by 2. That's just going to give us halves, right? So it's not going to be like gross decimals. So yeah, definitely not a bad choice as far as decimals go. So yeah, it's kind of a last step. Row 2 divided by -2. So 3 divided by 2 is 1.5. 1.5. 216 divided by 2 would be 108. So remember, each of those rows represents an equation. So that's, z equals 48. Y plus 1.5z equals 108. And then x plus y plus z. Of course, z equals 48, right? So 1.5 times 48, well, half of 48 is 24. So 48 plus 24 would be 68, 72. So what would we add to 72 to get 108? What number plus 72 is 108? 36, okay, so y must be 36. So then x plus y plus z, so x plus 36 plus 48, so 36 and 48 give me 70, 84. So what would we add to 84 to get 108? 24, so x must be 24. There's our numbers, right? 24, 36, and 48. Do they actually meet the criteria of the question? Right, so you go back and read the question and say, do they answer the question? We have 3 even numbers. Yep. Do they add up to 108? Well, they better, because that's the last thing we did. Is the smallest half of the larger? Yep. Is the middle number 3/4 of the larger? What's a fourth of 48? Well, so 3/4, 3/12 is 36. Check. Right? It's all them. Right? So just, a little short sentence. The numbers are. Right? This next section here is something I talked to you guys about, like when we were doing this. When I taught you guys this with the systems of equation stuff. I mean, I mentioned all this stuff to you guys. These are just kind of generalities. Like when you are doing applications, like these are the types of situations that tend to come up. Okay, there tends to be some sort of quantity equation. So again, we did a problem. I think it was like there's 29 coins, and you had nickels and quarters and pennies. And then it said that the total value was like $1.77. So there was a quantity piece of that, a counting piece of that, purely just like how many coins are there, right? I have 5 coins plus 7 coins plus 15 coins. Like how many coins is that? Nothing about value, right? So it says regardless of price, cost, regardless of value, like just purely counting. Kind of have that here, like purely counting the numbers give us 108, right? If I was thinking of like, a pile of ones and a pile of ones and a pile of ones, like I have 24 ones and 36 ones and 48 ones, like it's kind of just counting there, okay? But then we have value, right? So when you think about that coin thing, it's like, well, now how much are all my pennies worth, and how much are all my nickels worth, how much are all my quarters worth, and what's the total worth of my coins, right? We don't really have something like that here. None of these deal with like value of the numbers. But then you have to start, bringing that the 0.05 and the 0.01 and the 0.25 in, and then it gets you that 1.77, right? That the value plus the value plus the value gives you another value. It has to be consistent. Okay, I can't have like count plus count plus count equals value. That doesn't work. Okay? So the consistency there. And then the last one is those relationships. We saw 2 of those here. X is half of z, right? Y is 3/4 of z. Those are relationship equations. And I talked to you guys about that. Those are often the trickiest ones because they, the way we talk and the way the math works often switches. Here we saw that it didn't, that word is really helped us. We saw that there. But if it said that, there are 8 less quarters than pennies, like we really had to stop and think, like, does the 8 go with the quarters? Does the 8 go with the pennies? Like, which one was it? We had to make sure that it was the right way because it was easy to mix up. Okay. So watch out for those relationship ones. They're very common as a way of relating things. So just be careful about those. So in the end, this one's very similar to a coin problem, even though it's about simple interest. Okay? So talking about a city zoo that's borrowing some money, very large amount of money, and it's at simple interest. So a while ago we talked about compound interest. This is not compound interest where every month interest gets added on. It's not that. It's just simple interest. All it means is the easiest way to think about it is if you borrowed $100 at 5% interest, at the end of the year you'd have to pay that $100 plus $5 back. That's it. Simple interest. Okay, it's a simple annual interest. So whatever you borrowed times whatever the percentage rate is, that's it. Okay, that's simple interest. They borrowed $2 million, but they had to borrow it from 3 different lenders, it looks like. Some of it was at 8%, some at 9%, some at 12%. And that total interest they had to pay was $186,000. And the amount borrowed was at 8% was twice the amount borrowed at 12%. Okay, so there's all the information, and then you get to the question. And this is the first thing you need to worry about. What's being asked? Because the first thing we have to do is define the variables. What is X? What is Y? What is Z? Or what is A? What is B? What is C? Whatever you want to call them. Okay? What do they represent? So this question is asking how much was borrowed from each place. So each variable better represent a how much. Or a different way of saying that, an amount. Okay? I know the amount that they borrowed from one bank versus the next bank versus the next. So I'm going to say amount borrowed at. I don't want to write the word borrowed over and over again, so I'm going to say the next one's supposed to be amount at. Yeah. Each one of those is representing a certain amount that was borrowed at a certain percentage rate. So we get to decide what letters we use. We decide what order we write these numbers over here. We don't get to decide this. This has to be what the variables define. I can use a different word here. I could say how much borrowed at, but this is what the variables need to represent. You don't get to decide that. That's what the question is. Okay? The variables need to answer the question. And again, my habit is to pick the first thing. That's what the first thing goes there. And the next thing, unless there's something telling me that I shouldn't write that way. Which it kind of was like on the last one. Like I said, I don't want to write the second thing there because it's kind of silly to write largest next. So, but borrowed at 8%, borrowed at 9%, borrowed at 12%. And then we start writing equations. What do we have? X plus Y plus Z equals 2 million, okay? They borrowed 2 million total dollars, right? So that's a quantity question, right? That's kind of the easy one, right? Next one's kind of tricky. I don't think you guys have done, I know we haven't done a problem like this. So if you've done one, it's been a little while. The next thing is talking about kind of the value of the borrowing compared to its interest. It's kind of like like the count of the coins versus the value of the coins. So simple interest, this is the total interest they're going to be paying. So that's going to be like the answer over here. We need to figure out how to figure out what's being put together. So again, simple interest is just how much you borrowed times the interest rate. So I'm going to take X times 8%. When we say 8%, we actually have to say 0.08. Okay? So I have 0.08x plus 0.09y plus 0.12z will add up to our total interest. So I have a certain amount of interest from this account, a certain amount from this account, a certain amount from that account. They all get added up to give a total amount of interest. I'm going to write an interest equation, which is very similar to a value equation. amount I borrowed times the rate will tell me how much interest I got pay for that account. Amount I borrowed times the rate, that's how much I pay on that account. Amount I borrowed times the rate, that's how much interest I'll pay on that account. That would be my total interest. So interest plus interest plus interest equals interest. Okay? X plus Y plus Z, those are not interests. Those are amount borrowed. Okay? So you can't add those together to get that. So there's oh, we need one more equation. X equals 2Z. Where are you getting that, Maddie?
At the end of the question, it says the amount borrowed at 8% was twice the amount borrowed at 12%.
Okay. So the amount borrowed at 8% was twice the amount borrowed at 12%. So what's the amount borrowed at 8% to us? That's X, right? And then was is just the past tense of is. So there's our equal sign. And twice, of course, means 2 times. 2 times amount borrowed at 12 is Z. So X equals 2Z. So if we wanted to turn this into a matrix, which we certainly could, this would be a pretty tough matrix to solve just because of the types of numbers you're looking at. Because you have very small numbers and you have very large numbers mixed together here. And the chances of like working and losing one of those zeros as you're working with these is going to be super easy, like just dropping a zero off. It's super easy to do. So I would kind of give you a pass on this one as far as doing it in a matrix. And just go back and do it the way with a substitution elimination. I will show you how to set up as a matrix, just as a quick hint, but you guys wouldn't need to do a problem like this. If these numbers over here were smaller, I would say let's go for it, but it's just the combination of these tiny numbers here and these giant numbers over here is just going to make it a mess. So, and there are things you can do to deal with this, like we don't have to say 2 million like this. We could just say it's 2 and know that our answers over there are in terms of millions. But because this is in millions and this is in hundreds of thousands, we lose a little bit of that ability. So we could shrink things down over here and just call this 186 and just know that it represents 186,000. So then this could just be 2,000 because 2,000 thousands is 2 million. So we could shrink these numbers here if we wanted to, so we don't have so many zeros floating around. So that always is an option. So again, I will just show you what it would look like as a matrix, but you guys don't need to use it to solve it. So just like last time, we would need to switch this to x minus 2z equals 0 because we want all the variables on one side. So it would be 1, 1, 1, 2 million. That would be 0.08, 0.09, 0.12. And 18600 10 negative 20. So that would be the matrix. Our set to 9 are there. Just like last time, if we wanted to go ahead and get rid of the decimals first, we could just multiply that second row by 100, and obviously that's just going to make this number over here that much bigger. So again, you could do that. Have 8, 9, and 12, and then I think that would become 18 million. So if you did that, if you did switch it, 8, 9, 12, and that was 18.6 million, you could just write this as 18.6, and this one could just be 2, 1, 1, 1. So you could make the things easier to deal with. You just have to remember that when you get your answers, it's not 2, it's not 18, it's 2 million, it's 18 million. So if this turns out to be 5, like it's not that's, it's 5 million. If it turns out to be like 0.5, then that's, 500,000. So you would have to convert those back to millions at that point. So, but again, I think there's just too many little weird things going on with that one to ask you guys to do that. But that's kind of how you could approach it. You guys need to talk about all, like how you would do substitution elimination to solve this system. Do you guys remember how to do that? You need to talk about it real quick or no? Need any help with that? We can start it. Ruth, okay. So I'm seeing a couple things, Ruth, when I look at this. So if I'm going to do one of these, these methods here, I don't need to worry about this. I can just look at this one here. So what I would notice is that this equation doesn't have any y's in it, right? And so if I could get another equation that didn't have a y in it, then I could use those two equations that just have x's and z's. So I'd be looking at how can I eliminate y from these two equations, right? So I'd probably end up multiplying this equation by negative 0.09 so that I could then cancel that. So then I'd have an xz equation, and I have another xz equation. Then I could substitute x into that one equation. That's one way. Cancel y first, and then substitute x into that new equation. The other way would be just to go ahead and substitute x in right now. So if I take that 2z, put it there, take that 2z and put it there, now I have some z's I would need to combine, but I'd have two equations that only have y and z in them. And then I could look at how I could eliminate y or I could eliminate z next. So doing things in different orders, but essentially doing the same two steps. So do I want to substitute first and then eliminate y or z, or do I want to eliminate y and then substitute? It's kind of half a dozen one, 6 of the other. Does that make sense, or do you want me to write something out? Ruth, you there? Okay, you're good? Yep. Okay. Well, let's look at this last one. It's set up, I don't like, and this problem is a mess just because the way they typed it. And they get into this whole chart business here in the notes. I don't really find the chart that useful, but that's me. The last problem on your worksheet is like this, except for I've separated the information out into bullets, so you don't have to weed through this mass of words and numbers here, okay? So this is particularly difficult because it's just all squished together in this big paragraph. But it is also quite different in format than the other problems we've done so far. So, so just, we are kind of running short of time. So I just want to point out that they're talking about having a certain amount of protein, a certain amount of carbohydrates, and a certain amount of vitamin A for this meal that this dietitian is trying to make for her patient or their patient. And that there are different types of foods that are being served. And so basically the dietitian's job is to say, how much of each food should that person get in order to get their needs met? Well, each food has a certain amount of carbohydrates, protein, and vitamin A in it. So the dietitian needs to find the right combination of those things. So they have, the halibut that they're serving has this much protein. The sweet potatoes has this much protein. The spinach has this much protein. The halibut has this many carbs, this many carbs for the potatoes, this many carbs for the spinach. And then the halibut has this much vitamin A, potatoes has this much vitamin A, the spinach has this much vitamin A. So what's different here, what we're, again, and then the last thing you want to pay attention to is the question, right? What are you supposed to be finding? This is what X and Y and Z need to represent. The question is, how many servings? So my X and my Y and my Z better represent numbers of servings. So I'm going to have so many servings of one thing. I'm going to have so many servings of the next thing. I'm going to have so many servings of the third thing. Again, I get to pick which letters I use. I get to pick what order I write them in, but they have to all represent a number of servings, because that's what the question wants you to find. Okay? And so again, my habit is to go in order. So first thing they say is halibut, so that's the first thing I'm going to define. Next thing they say is sweet potatoes. It's going to say potatoes. Last thing they're going to say is spinach. That's what I'm finding. X is going to be the servings of halibut. Y is going to be the servings of potatoes. Z is the servings of spinach. This is definitely something that somebody would do, but they wouldn't do it by hand. They would do this in a computer. Okay, and the computer is going to go and draw. They would basically say, "Hey, we're having halibut." The computer would go and would pull all the information for you. Okay, it's going to have this much of this, all this stuff, and you say and potatoes. It's going to go and pull all the information for you, and then it'll do all the math for you. But somebody had to write the program that's going to do that, and that program is going to use a matrix to do this stuff. Okay, so how do we get the program to learn all that math? All right, it's just going to do row operations. Okay, we can do row operations, but it can do it thousands of times a second. Okay, but those programs have to come from somewhere. Somebody has to write them. So what's different about these equations than maybe normal? It kind of is almost like a value equation, in that the things that are like each other have to go together. Consistency, right? I can't take protein and add it to carbohydrates and add it to vitamin A. The proteins have to add together to give me my total protein. Carbs have to add together to give my total hydrates. Vitamin A has to add together to give my total vitamin A. So I'm just going to take all these things here in red and add them up to get the other thing in red. So it would just look like this. And then I would just do that with the other two, just add all the things in blue, add all the things in green, and they would just give me my equations and I could solve those. So I'll make sure I